Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
You must have a good, reliable digital communication so that the remote pilot can be, at any time, be the pilot in command and therefore fulfill this legal obligation.
Hey everyone, welcome back to The Vertical Space and our conversation with Thomas Neubauer, co-founder and CEO of Dimetor. So you'll have to stay with us on this one as we launch into the relevance and importance of connectivity using cellular networks and the intersection of cellular networks in aviation. We're fortunate to have Thomas to help us walk through this complex topic. Thomas discusses the long-standing requirement of having a pilot in command, and that you must have good, reliable digital communication to ensure connectivity to fulfill this pilot command requirement. We discuss how beyond visual line of sight operations are being enabled via cellular networks. It's also interesting to hear about the gap between communication service providers and aviation ecosystems, why it's relevant, and what can be done about it. We go into depth on the strengths, weaknesses, and risks of cellular for command and control, as well as other options that may be available in place of or to complement cellular, where some people, for example, believe you need dedicated spectrum. Thomas is the architect of Europe's UTM interface standard, so he discusses the standard and why it was developed. He also discusses how the drone could be considered an IoT device, or as Thomas says, Aerial IoT, and its relevance. Finally, we discuss Thomas's company and product, Airborne RF, problems they're addressing, their customers, and how they generate revenue. Listen, we hit so many topics and relevant topics in this podcast, it's impossible to summarize them all up front, so just take a listen. We thank Thomas Neubauer for joining us, and to our listeners, we hope you enjoy our discussion with Thomas as you innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Thomas Neubauer is co-founder and CEO of Dimetor. He has about 20 years of experience in the management of wireless networks. Among other innovations, Thomas is a co-creator and inventor of Airborne RF, a software solution specialized for connecting cellular network operators with aviation systems to include ATM, UTM, and FIMS. Thomas also serves as VP of Business Development and Innovations at TEACO. On behalf of GSMA and GUTMA, Thomas is leading the interface for data exchange between mobile network operators and UTM system workgroup of ACJA since it was formed in 2019. Thomas also serves at the board of directors of the Global UTM Association. As such, he is focusing on global standardization of interfaces between cellular and unmanned aviation systems, including 4G, 5G, and SATCOM technologies. Thomas holds a PhD in telecommunications engineering from the Vienna University of Technology. Thomas, welcome to the Vertical Space. Great to have you on. Let me ask you our first question. Is there anything that very few in the industry agree with you on?
Well, if you would have asked me that question several years ago, I would have had a straight answer that there's, in aviation, there's no need for cellular. As you know, the only link by the time was please switch off your mobile phone when you are entering on an aircraft. But the things have changed, and these days we are actually seeing and getting confirmed by the regulatory authorities that say cellular is a safety critical requirement to make uncrewed aviation a success. So that's how things change, and that has happened over the last few years.
And a few years ago, when people were not agreeing with you or felt that this was controversial, what was your pitch, Thomas? Why were you saying it was so important? And how are people agreeing with you now on that message?
It's actually very simple. And it goes back to the ICAO, the International Civil Aviation Authorities and Organization, back to the 50s, because they have defined that for any aircraft, you have to have a pilot in command, which is a legal requirement. And in traditional aviation, that pilot sits on the aircraft. And with the pilot sitting on the aircraft, it doesn't matter what other systems you have, radar system, voice communication systems, and so on. If they all, stop working, you still have the pilot on the aircraft responsible for the safety of the flight. That very same rule applies also to uncrewed aviation. But now the pilot is no longer sitting on the aircraft, but controlling it remotely. And in order to comply with that very basic and fundamental rule and law in aviation, to have this pilot in command, you must have a good, reliable digital communication so that the remote pilot can be, at any time, be the pilot in command and therefore fulfill this legal obligation. That's how things have changed.
And Thomas, what are the rules and regulations when it comes to the use of cellular signal for everything that flies, manned or unmanned? And how does that differ regionally across the world?
It's actually quite a good question, because it does vary between the different, global economical systems at the moment. And the reason is that some are a little bit more advanced when it comes to the so-called BVLOS, beyond visual line of sight drone operations. So those who already have some rules and regulations in place, they actually do not describe what the technology has to be to have this digital communication to fulfill the pilot in command requirement. All they're saying is you must show evidence that a remote pilot can be in control of the aircraft throughout the entire flight. And so it could be a satellite communication. It could be a fixed radio link. It could be, all sorts of other things. And among all these technologies, the one that is actually easily the most advantageous in the lower airspace, so, up to about 400 feet, 120 meters, 150 meters, it is cellular that provides, all the different ticks in the boxes. For example, you need to have a very reliable communication. You need to have a low cost because you're, going into a mass market. You need to have scalability. You must have security. You must have lightweight transponders. You must have low latency. You must have low power consumption. You must have, for some of the communications, broadband. And so for all of that, cellular, terrestrial cellular infrastructure is by far the best technology wherever it is available, with the limitation, obviously, that cellular has not been built for the airspace. It has been built for the operation on the ground.
Right. And outside of the rules that govern BVLOS flights of unmanned systems, what about aviation ICAO level rules? Is there a limit to the use of cellular, perhaps as a function of altitude or the type of commercial operation?
So it's a very good question, because what the aviation rule makers, so for example RTCA and in North America, EUROCAE in Europe, what they are defining is really how to communicate. So they define what the requirements are with regard to availability, continuity, latency, and integrity. So they do not define, if there's any specific frequency band or any altitude that you can use it. That is not subject to the aviation regulation. That is subject to the spectrum regulation. So the spectrum regulation authorities, they are actually defining what sort of technology and what sort of frequency band is allowed for aerial usage. And then it gets quite interesting, because what you obviously need to provide in the airspace is you must have some sort of a service level agreement. You must have some sort of a minimum requirement that you can provide as a guaranteed performance level. And in any of the unlicensed spectrum, Wi-Fi as an example, you have legal obligations that in a Wi-Fi spectrum, in an open spectrum, you cannot provide a minimum performance requirement, an SLA. You can just not do that because it's, the tragedy of the commons. If you have commonly used resource, you cannot guarantee individual SLAs. So therefore, the cellular spectrum becomes actually extremely valuable for that, because there you can provide an SLA. And for example, the aviation or the spectrum regulatory authorities in Europe, they have already defined what sort of frequencies, what sort of spectrum is allowed for safety critical communication in the lower airspace. So that has already happened. And in other places, it's, progressing. At the moment, the status is what is not allowed, and therefore all the other stuff is allowed.
We're framing the conversation nicely to perhaps have a conversation about how practical and realistic is it to build a reliable, robust, high integrity, cellular based command and control system. First of all, let's describe the challenge of using cellular for C2. And let me frame the conversation in this way. And please, Thomas, just correct my understanding of this. But obviously, it fixes the range problem, but there are still broadly two main sources of challenges. One's the interference, and the other one is, let's call it, cell association or mobility. And with the interference, unlike on the ground use cases where signal to interference ratio is good, and plus buildings provide some kind of cell isolation, when a drone is flying in the air, it sees many more base stations within its line of sight. And so interference works, and it works both ways. A drone is both suffering from it as well as generating it. So that would be the interference piece. The cell association mobility piece would be that unless the drone is taking off or landing, it will likely not see the main lobes of the cellular signal, which is tilted down from the base station, as we know, to optimize for the ground users. So how is the industry dealing with these two main buckets of problems? Or perhaps there are some others.
Right. So I think you're addressing some very good questions on that. And that issue has been addressed in the following way by the industry. So about 5 years back, the aviation industry, the unmanned, uncrewed aviation industry, recognized that connectivity is something that is absolutely critical to fly really beyond visual line of sight for all the different reasons, pilot in command being one of them. Therefore, they tried to figure out, so how can they answer the information, or how can they get answers to the questions such as, how does cellular perform up in the lower airspace and to what altitude? Because there is a number of aspects, right, that you just don't see on the ground, and the cellular networks are built for the ground. So, and that is one question. And the second question is how to get access to that information, how to get that data as an additional data layer, like like wind and weather. You make a forecast for your flight, and then you still need to check if there's a thunderstorm coming along. Is there something like, mapping this connectivity, the interference and the mobility? Can that be done in the airspace? And for that reason, the representatives of the telecom industry, called GSMA, which are representing the telecom mobile network operators, and on the aviation side, GUTMA, the Global UTM Association, have actually joined forces and generated something that is called Aerial Connectivity Joint Activity. And that is dealing with all sorts of different aspects. Number one, what is already existing in the telecom standards to deal with, cellular for the airspace. On the other hand, what are the requirements from the aviation regulators? And then in the middle, how to generate interfaces that allow the exchange and the processing and the computing of that data to actually make telecom information available to aviation systems. And for that very reason, so I have the privilege that I have been one of these founding members of this ACGA, and I'm actually leading the global harmonization and standardization of these interfaces. And as part of that, we have been very closely looking into What does it mean when we have interference increasing with altitude? And the first step to actually fix the issue is to understand it. So the first step is to understand, based on the live network parameters, based on the live conformance and performance information from the telecom equipment, how does that reflect sort of a three-dimensional connectivity map that changes over time? How can that be generated, and how can that be exchanged in a safe and secure manner for the different phases of a flight? So that means for a flight plan, for a flight approval, and then for a flight operation, so an in-flight procedure. Because if anything changes in a cellular network, which is by definition a best effort network, how can the aviation systems be informed and updated about it? So that was the first step, to identify what is needed, how to generate an interface so that we have visibility on what is going on. And as soon as we have that, we can then actually start looking into how can we improve it. And here comes the good news. The telecom industry has actually been looking up to the sky over the last 8 to 10 years. So already in what the standardization authorities are called 3GPP in the telecom environment. And in a release 15, which was released 7 years ago or so, already they had capabilities embedded in the standards for terrestrial cellular networks that enable and allow connectivity services in the airspace. So the telecom industry has prepared for it. And to that point, when it comes to interference and mobility, there is a really great feature in the latest 5G technologies out there that is called network slicing. And what network slicing really does is it enables cellular operators to provide essentially a virtual network running on the same physical infrastructure that behaves like a dedicated network. So you can think about it as, you have a pizza and you take one slice and you dedicate that slice to a C2 link in the airspace. And that means you make it independent from the interference of the remaining network, even though it's running over the same physical infrastructure.
Thomas, how is this different from dedicating a piece of spectrum?
The beauty of it is that you actually can do that in a fully adaptive manner. The problem if you have a dedicated spectrum, it comes with dedicated infrastructure. In most cases, like antennas that are looking into dedicated spectrum, you need to have equipment that actually supports it. You need to have transponders that actually support it. That is usually, some of these, we have dedicated spectrum for aviation purposes, but who deploys at spectrum that is sort of not as advantageous as we have in the regular cellular spectrum, which ideally we want to go as low band as possible from a range perspective. It's essentially building on all of the benefits that you have, and you can adaptively allocate those slices, and you can control the performance of those slices. And if the conditions are worse, you can allocate more spectrum to achieve the same level of performance. So it has a lot of advantages to actually have that as part of a larger spectrum, but adaptively controlled and managed.
At some point, we have heard also of certain attempts to do new types of signals for a drone user so that the network knows that a user is a drone, or some new power control mechanisms to improve interference. Have those yielded any good results? Are they baked into this new wave of thinking how to leverage cellular for unmanned systems?
So that is, as you point out, that is one of the first things that have actually been implemented. That you have to an airspace user requires a SIM card that will fly in this airspace, will require a different authentication than you have on the ground. And the reason is that you're actually enabling additional safety critical services that may not be required if you're watching a football game on your mobile. So there are specific safety related services that are part of the telecom standards. For example, there is a functionality called ultra low latency, ultra reliable communication. You don't need that for watching, videos on your mobile, but for things like drones, it can be very important. And also, there are specific, prioritization aspect and other services that come along. So, bottom line is, in order to enable a mass market for connected drones, so anything that flies BVLOS, you will have to authenticate specific services. And this is part of the standard in telecoms for many years now.
How do these new methods deal with the fact that the higher that an aircraft flies, the greater the interference, the more cost the network is of the interference?
Coming back to this capability of the network slicing. So the beauty is that you can not only actually separate sort of a virtual part of the pizza to the airspace application, you can also configure your network, your sort of virtual dedicated network. You can configure that separately. So anything, if as you point out, if you have a very dense network build out, you're experiencing more interference up in the air. Well, if you're doing a dedicated virtual slice, you can actually configure it such that not every cell is actually taking part of that communication. And therefore, you can generate a dedicated performance up in the airspace, which makes it behave like built for it. We're not there yet because the business cases don't support it for the telcos to implement, but at the moment. But the technology is out there and the capabilities are there, and it's going to happen, and it will enable a wide range of drone services, for first responders, for delivery, and so on. And as you pointed out, it also works the other way around, right? Communication channels are reciprocal. So the telecom providers also have a desire to protect the network, because if you have sooner or later somebody sitting in an autonomous air taxi, advanced air mobility or urban air mobility, if I would sit in there, I would actually stream a video on how cool it is to actually fly there in a flying robot. That high data rate video can actually potentially do some harm to the remaining network, as it sort of comes from top down and is not considered in the original design. So therefore, you need to understand how that is, how that works. And once you know that, you can actually configure it such that it does not do any harm for any of the other users.
Some critics of use of cellular for C2 would say that if you want to build a truly scalable system that is good to use for safety critical applications and services, that you really need dedicated spectrum. How would you respond to those critics?
Well, what aviation is looking for is actually redundancy from a safety perspective. So you can always deploy dedicated spectrum if somebody pays for it. But for the industry to scale, we have seen that, for example, in public services network, in first responder networks. What you typically have seen is that you take some of the existing spectrum and you have a telecom operator operating that under the same terms. And that means you get modem prices down to mass market prices and not to high-end, whatever super duper technologies. I'll come back with some examples. For example, for electronic conspicuity, the airspace regulators are actually going exactly that way, and that is general aviation. They are now making cellular already an acceptable means of compliance for general aviation. This is like a massive U-turn. As a couple of years back, you have been told, switch off your mobile when you're on a plane, it's a safety risk. And now you're getting told, well, hang on, as a safety feature, we are recommending to use cellular in the airspace. So this is quite a shift in the mindset. And the reason really is to make it available at scale in a cost-effective and trusted manner.
Speak to what commercial aviation is doing today as it relates to communication. What's the corollary, and how does it relate from a reliability, security perspective? How does it relate to the cellular for unmanned?
What communication technologies aviation is using today is primarily voice. Tiny, tiny, tiny little data communication is needed. You have active radars on the ground and on the aircraft. And again, coming back to my original point, you have a pilot. So the pilot is essentially, responsible for everything that happens if you're losing connectivity. And therefore, it's not such a critical aspect because you have this pilot on board. That is the fundamental aspect. And that's where we see exactly the huge gap. If you look into helicopters, so any participants in their sort of lower airspace, and I'm not talking about the infotainment, because for infotainment and streaming and email services on a regular aircraft at 30,000 feet, you have very different solutions. Even though there you see some cellular infrastructure actually pointing up to this higher airspace. But in the lower airspace, things like helicopters, news feeds that are transmitting on that, it's to some extent trial and error. Because they do not have any proper infrastructure, any digital infrastructure that is dedicated or built to actually serve this airspace. That is exactly the reason why we see in some countries, I take Sweden and the UK as two examples, where the government has built out dedicated cellular infrastructure that serves the digital airspace in an altitude of up to about 3,000 feet above ground. For that very reason, to provide a digital infrastructure for the airspace. And we see more of that happening now, especially with the rise of the uncrewed aviation. We see that with the regulations, for example, in Europe kicking in, there's a legal requirement, that every crewed aviation in this lower airspace also makes itself electronically visible. So it's called e-conspicuity. And for that, you have some traditional technologies like, ADS-B, so some broadcast transceivers or broadcast transmitters on the aircraft. But that is fine if you have an aircraft, a proper aircraft where you have people flying around. But for other participants in the airspace, such as paragliders, ultralights, the cost is actually excessively high. And therefore, the European Aviation Safety Agency, EASA, the equivalent to the FAA, has actually made cellular now an acceptable means of compliance to provide something that is called ADS-L, so a light version without a dedicated transceiver, but every paraglider pilot, as an example, has a mobile phone. So why not make the information about other airspace participants and weather information and updates and critical information for the airspace directly available on a service, on an application using the cellular infrastructure? And that is exactly what the regulators have now done. By doing that, it means this is a general aviation compliance and a general aviation application utilizing cellular for a safety reason. And we see the same thing happening with drones, where the authorities have approved cellular spectrum to use up in the airspace. And we see even for other active interactions, tactical deconfliction systems, and so on, there's a lot going on in the cellular industry to support that as a safety supportive system.
It's interesting when you mention ADS-B. Let's draw an analogy to the way that the traditional incumbents look at this new emerging drone market. In traditional aviation, we have seen, certainly in the US, they have been very protective of ADS-B and ADS-B used by drones because of concerns of oversaturation of the spectrum and interference and overload of air traffic controllers, et cetera, to the point where they banned ADS-B use by small UAS. How does that translate to the potential fears that traditional telecom ecosystem has on the similar overwhelming of the existing cellular infrastructure if they think about the market that will exponentially grow?
Well, if you're talking to a telecom operator with millions and millions of existing customers where you're providing service levels to them, generally speaking, the telecom industry is not scared at all about adding some safety critical additional customers that are flying around.
Are the telcos concerned about the impact that drones might have on its ground user base?
We have done analysis with actually some customers in the US where we have investigated that. And the answer is yes, there may be some impact when it comes to scale. But there's actually a number of capabilities that you can do to mitigate that. Number one, the infrastructure itself will provide some capabilities to mitigate some of that interference. Number two, you can do actually a lot when it comes to the antenna technologies and antenna designs on the aircraft, irrespectively how big or small it is, because you essentially, by having a more reasonable design of the antenna system on the aircraft, you can sort of blend out any signal that you're receiving from 30, 40 miles away. And that works both ways. That is one aspect. And the other aspect is, as I mentioned before, by having the possibility to actually authenticate SIM cards that are up in the air, you can as well block SIM cards that are actually not following the rules up in the air. So if it's not an authenticated service and somebody wants to put the cheapest possible SIM card into a drone and stream high data rate videos from in dense urban environments, they will not get authentication and therefore they will not be able to actually set up a connectivity. So there's a number of protection mechanisms that are already part of the telecom standards, and there will be a number of engineering capabilities around where they can identify where are these sort of signals coming from and mitigate them, especially with 5G. There's this network slicing is one of these capabilities. If you bring them to a dedicated network slice, you essentially separate them virtually from doing any harm to your remaining customer base. And secondly, you also have something that is called MIMO antenna technologies at the base stations that will allow you to actually sort of physically separate the channels coming from above in a more effective manner. So there is a number of technologies out there that helps the telecoms to actually separate and mitigate and reduce therefore the impact that a drone may have on any terrestrial customer experience and performance.
Talk to us about the different cultures that exist in aviation regulatory bodies and the telecom industry. That has traditionally been a bit of a pain point, and they seem to have struggled with finding a common language. Now, with your perspective from the Aerial Connectivity Joint Activity and the GMSA and GUTMA, you have a very unique insight into this. How has this relationship, if you will, evolved over the years?
It is actually very interesting to watch that because we see a little bit, back and forth on, for example, let's take the two large blocks in the US and in Europe. I can't say North America because Canada is essentially following the European model. But the key point is there are some differences, and the most significant difference in the US, we have two categories more or less of aircrafts, the ones that are certified and the other ones that are not certified. Whereas in Europe, we have three different categories, and the three different categories are that you have the open category, and then you have the certified category, but in between, we have something that is called the specific category. And the specific category has been introduced to actually not have this 0-1 switch, but to have a gradual risk and performance-based introduction of beyond visual line of sight operations. So in Europe, you can do with uncertified aircraft, you can do BVLOS if you're following the rules of the specific category. And for that, you need to do something that is called, a risk assessment And based on what you want to do, based on your mission, you have different categories. And the more advanced your mission is, the more you're moving to the certified category, the more you need to fulfill requirements. But if you're flying over open land for the inspection of infrastructure, you have some more relaxed capabilities, and that is implemented in a procedure that is actually part of the regulation. And therefore, the current stage is that these procedures are being, in the process of being automated. And by doing so, you can have a risk-based automated procedure sooner or later that allows you to fly based on your risk under certain risk categories with different aircrafts that are, ranging from essentially open category to a fully certified aircraft. And that, I think, is at the moment the key driver for actually enabling the business. Because otherwise, the certification process is very long and you need to have all these procedures as with a regular sort of aircraft. But that may not be, for some, it's deemed not fully appropriate because the dynamics that happen in the drone industry are having so much shorter development cycles that you can't go through a full certification process in order to make it a viable business opportunity or drive a viable business opportunity. And that's why we see that most of the world is actually looking into that concept where you have that middle stage that is this specific category, and within that specific category to have a gradual approach towards subject to the risk, air risk and ground risk assessment. And that is where, closing the loop, that is where you have then again cellular coming in quite a lot, because for these risk assessments, you need to have an accurate picture on what is the connectivity up in the air. You need to demonstrate that you have evidence of the connectivity along the flight path. So getting these interfaces to provide that information becomes pretty important. And the other thing is the risk information about the ground risk. And that essentially means how many people are on the ground along your flight corridor. And while in traditional aviation and up to now also in uncrewed aviation, census data is used for that in different flavors. But census data essentially gives you information about where people are registered or have been registered in the past. And that does not give you any information about where people are at the given point in time.
Is there any issue with making that data available from the cellular networks? I mean, if it's de-identified, is it any issue at all?
Well, from a GDPR perspective, no, because nobody is interested on where Thomas is, right? Aviation is just interested along my flight corridor. Do I have, a people density per square mile or per square kilometer of 250, 2,500, and so on. So getting back to the categories of the aviation, and therefore telecoms providing that aggregated information is not violating any of the safety, security, or privacy aspects at all. It's adding a huge amount to the safety because everybody who is commuting knows that where, depending on time of day, the traffic and therefore the people density is very different.
Okay, so for a given telecom network, in a given location, you collect data about the performance of that connectivity over time. And historically, is there a clear and consistent picture as to how much that connectivity performance varies? And is that something that we're able to assess as part of the safety case to understand how consistent this is?
Correct. For a living, I'm help producing software that actually sits at the telecom operators, processes that data so that it can takes also historical data so that we can make projections based on the live performance, and the historical information about cellular networks are loaded differently at the time of day of week, and so on, also seasonal. And based on that, we can very accurately give you information about how the performance at any given airspace volume will look like and does look like. And during the operation, even provide live or close to live information about how it performs. And according to the airspace regulation, it's what is called a conformance monitoring. In new business talk, we would say it's a digital twin. So essentially, what we are generating is a digital twin of the airspace connectivity and the ground risk information, and make that information available to all of the airspace stakeholders in a standardized manner so that it becomes an acceptable means of compliance. So we're working with the regulators to make that happen with a globally standardized interface. And in ACGA, we have defined those globally harmonized and standardized interfaces. We have agreed between all the telecom stakeholders and the aviation stakeholders on how that data can be exchanged and for what reason. And that's how it's actually currently being implemented.
Okay, but to help us and the audience form a picture of this, for a representative network, how much does that performance vary over time? Are we talking about single digit percentage variances, or are we talking about 20%, variance over time? Help us sort of form a picture of this.
You need to realize that cellular networks are highly dynamic. So carriers, for example, are switching off particular carriers depending on time of day and utilization for energy saving. If your network is not used, they are switching off particular carriers. And therefore, you have a different, what is called the capacity layers and the coverage layers. So they are dynamically put on and off because it makes sense, because the energy bill is actually the second largest item, or in some cases, the largest item on the balance sheet of the telecom providers. And on top of that, the network is loaded very differently. And therefore, some systems are actually continuously so-called self-organizing network functionalities are continuously reconfiguring the network. So it does have an impact, of course, onto the airspace performance. Generally speaking, the way that we are doing it is by providing a big picture. It's a bit like, a weather forecast, where you get a weather forecast a week ahead, but the aviation procedures then actually request you to have, just before the flight takes off, that you have a so-called flight clearing procedure. And for that flight clearing procedure, you have to check with the latest and greatest data from the network, is the current situation as you have expected it for the approval, is it actually still in that ballpark? And if it's okay, the threshold is it okay or is it not okay? So we're not talking really about does it vary a little? No, nobody worries about that. The question is, are we having any changes to the network that are material?
Thomas, how do you convince both regulators and operators that your connectivity mapping can be trusted for safety critical applications?
By extensively testing it out. So, for example, the FAA has a couple of years ago started some very extensive test work in a multi-year engagement with some major carriers in the US to actually measure and identify if and how the cellular performance in the airspace is sufficient. And also, we are working same thing here now in Europe, how that can actually, how accurate and reliable is it to forecast? And because of having a digital twin, which is not a forecast, but where you get continuous feedback from the system, from the drones, from anybody in the airspace, you get a very reliable picture. And also in this ACGA, we have conducted measurement and are conducting measurement campaigns around the world, where we actually looking into this on how can I forecast, and because aviation requires that anyway, how to make sure that we get real-time updates because it's not only the ongoing performance changes in the network, there's also, what is called maintenance outages in a network, right? If people are swapping antennas, if they're maintaining a cell tower, they know that in their databases because they have work orders for it. And so we're accessing that type of data also to inform the aviation systems about, for that time of day or for that day in a week, there's this and that connectivity change to be expected. So it's like aviation people are familiar with the term NOTAM, a notice to airmen. If you think about that in a similar way for connectivity, that is what we are providing.
Thomas, you mentioned in the beginning of the podcast that there were those who didn't see cellular networks as a solution a couple of years ago. What were they advocating? Let's say this capability was not available. What were they advocating?
Some from traditional aviation, are leaning towards dedicated networks. Some are leaning towards satellites. And the challenge with all of those is the commercial availability, the broadband capabilities that are also needed, and of course the latency aspects that you have, and at the end of the day, cost. So because that changes the risk profile. So let's take satellite as an example. You can have some latency that is, goes into seconds with a so-called L-band transmitter. We will see some changes with the LEO and the high band low orbit satellite systems, but they have other disadvantages. Like if you're operating a LEO system in a high band, you have antenna sizes that actually do not favor any deployment on a drone. So there's these compromises. And what we have seen is that for the cellular infrastructure in the drone industry, it's not only the safety related aspect, but these drones are also generating a huge amount of data. If you think about any drone as a first responder, you want to automatically dispatch a drone and have it fly to an accident or whatever, and you want to have a streaming video or pictures transmitted back to the mission control center. This is broadband. We are talking 5 megabit per second. Good luck with having that on a traditional satellite. So what I'm saying is there's no one size fits all, because satellite and terrestrial are in that case actually a perfect complement. And that is what aviation these days really came to realize, is they actually work well together. And you can have a C2 link on a satellite where there is no terrestrial connectivity, just to make sure that you have sufficient control mechanisms. But as soon as you go back to areas where you have broadband, you can then transmit signals again at a much lower latency, much lower cost, and so on. And so we're working with some partners who have transponders that do support both cellular and satellite for the drones. Obviously, this is also a cost question, but ultimately we expect that wherever cellular exists, and that is, in built out areas, like for any of the delivery services, for any of the first responder services, in almost all cases, cellular exists. And there it will be easily the preferred technology.
Where does a drone operator go today to obtain real-time population density data?
That's a very good question, because many of them really struggle, but it starts actually with one step before. Even if in some cases, even if they could get it, some of the regulators do not accept it as an acceptable means of compliance. And that is, for example, changing now. So in Europe, we have this SORA, the Specific Operation Risk Assessment. And by the end of this year, there's another one. Well, it's not a European thing. It's actually a global thing. SORA is introduced by JARUS, which is a global organization. JARUS is the Joint Authority for Rulemaking of Unmanned Systems. And JARUS is introducing SORA 2.5. What we will see there is to have some more dynamic risk assessments that actually require, in order to make any use of it, so-called M1 mitigation, that you have some more dynamic information about the ground risk. than census data, because census data doesn't give you anything on that. You can make a test, right? If you're visiting a sports event or whatever, nobody in the stadium will, well, probably less than 2% of the people will actually be registered in the environment where the stadium is. And to have that dynamic data, it's the telecom providers who have that information. There, sooner or later, there may be also some additional service providers that do some aggregate information for that. But telecom providers have some very good understanding of it, because for the last 10 years, they're using positioning information for very different reasons. For the performance understanding, for the analysis of the performance, for the enhancement of the network. And with COVID, we have seen that, these mobility reports on, if you have some lockdowns and how effective are these lockdowns, that is all based on mobility data coming from telecom operators. And so now aviation is the next area where that data can be utilized in a safe and secure and GDPR-conformant manner. And we help them by generating interfaces so that they can access it.
Sorry if I missed this, but why is it not practical for a drone operator to go to the telcos and obtain this data? Is it a matter of guarding this data as some proprietary data that the telcos are not willing to share? Or is it a matter of, okay, you can have the data, but the aviation regulator will not give it any seriousness or any credence?
So the answer is the drone operators would love to get that information, but it is probably one of the highest classified data sets at the telecom operator, because usually it has a lot of privacy and other aspects attached to it. And it's therefore, even within departments, within the telecom organization, they're not allowed to share the data as such. So what we've done also with this ACGA work is we have helped finding a way to actually process the data such that only the information that is really relevant for aviation and uncrewed aviation is extracted. And therefore, the telecom operators are no longer then sharing any classified information, but unclassified results that are sort of providing the envelope that is along a flight path for the telco, for the aviation, for the drone operators, because all the drone operators need to know is, am I good to fly over here or not? They're not, they don't even need the absolute numbers. If you have a drone, that can fly over a certain number of people from the certification and the specification, the request is that now good enough or not? And that makes it a very different value proposition and a very different information that is exchanged, that is no longer classified. And the same actually applies for network configuration. In some countries, the configuration of a cellular infrastructure, even the position of the sites and the antennas, is a matter of national security. So telecom operators would never be able to share, even if they would want to provide that information. But with what we have done over the last years, we have actually demonstrated they don't have to provide any of the classified information at all. All the drone operators need to know, do I have connectivity there or not? And this is how we are helping.
What's a timeline for a product that will show this data in a way that satisfies both the telcos and regulators?
We have actually commercially launched services for that already in Europe. So we do have, and if I'm allowed here to name it, Vodafone, for example, in Germany, they have launched a service that is called DroneNet, which provides exactly the information that we're talking about. So they provide the information on where in the airspace do I have sufficient connectivity to fly beyond visual line of sight.
What about real-time population density? When do you think that we'll have that kind of product available?
So the products are available today, and we know that air navigation service providers, so the approval authorities, are already approving flights on that basis. There will be, however, a broader regulatory move that will enable and allow it later this year. That is happening. That is not, that is based on the JAROS and definition of what is called the SORA. And even in the US, we have now some agreements that they are looking into global harmonization. And I think the regulation spells it out as SORA-alike capabilities, so that you have essentially ground risk assessments that are enabling you to access and assess dynamic. I would call it dynamic because not every time it has to be live. It only has to be live if something is outside the boundaries of what is allowed. But the general information is that you know your time of departure, you know your time of flight, and for that you need to understand what is the dynamic risk on the ground for that time. And if anything changes, like crowd gatherings and so on, telecom operators already have solutions available to provide that information even in close to real time.
So you're saying you expect a formal approval as an acceptable means of compliance later this year?
Correct.
I sense some of our listeners clawing at their phones as they're listening to this. So there's two things that are hitting me. One is, if this is viable where there are cellular networks, aren't most drone and BVLOS operations today where most cellular networks are not?
That has to do with the regulation. So because at the moment, in the US in particular, you're essentially flying BVLOS on waivers. And the waiver acceptances you get where you can do very little damage. And so it is in Europe. But that is going to change significantly very soon, because where can you get the biggest value of BVLOS is not about the fact of that you have a BVLOS and you don't see the drone, but you have a relationship of one to many from a pilot perspective. So anywhere where you actually want to have scaled drone operations, that being, anything that is related to first responders, anything that is related to drone delivery, and that will only be, by definition, work where people live. So that is where this next level of BVLOS really comes in, and for that you look, the term I would like to use is fully automated BVLOS.
Mm-hmm.
Because at the moment you have either some airspace observers, or you have some who gives a toss if the drone comes down because nobody lives there and the damage is very limited type of environments. And that is where where you see some of the operations right now, because it's test phase. But the real test will come with the mass deployment, and that will actually come in places where people do live. As I mentioned, delivery, as I mentioned, some of the inspections will also work, and the huge area of first responders you will need to get this automated, and for that it will move to the areas where people live.
Let me ask the second question. Thank you. Am I going to get 20 emails after this podcast from air traffic thoroughbreds around the world who are saying this is not practical, that the level of safety required for aerial vehicles is greater than what would be otherwise available from a cellular network? Is that a legitimate complaint?
So the way this is handled, as I mentioned, any communication system, any commercially available communication system, no matter what it is a best effort. So what the regulations and the concepts of operations in the aviation actually do to overcome those limitations are the following. Number one, you must have some level of redundancy. So for example, work with multiple and have a fallback. And depending on the risk of the mission, your fallback may look different. You may have a second telecom provider. It's mandatory to have 2 SIM cards. It's in some cases it may be mandatory to also have a satellite fallback. And most importantly, aviation, you don't need to have 100% connectivity. You can have some gaps, because aviation will have other mitigation technologies to make sure that you are fully compliant with the safety regulation. So parachutes are one of the aspects, or other, or fly back home. If you lose connectivity, automatically fly back home. So there's a number of safety, or fly back to the next place where you knew you had last time communication. So there's a number of mitigation technologies that make sure that you have, multiple levels of redundancy. And that's why it's very important to know where do you have connectivity, because the worst thing that you want to have, and I can give an example from practical first responder implementations that we work with. They say, hey, we dispatched a drone and we wanted to fly to the scene where there was an accident, but you know what happened? The drone flew back because it lost connectivity. And so you cannot dispatch a drone into an airspace where you have no idea if there is connectivity or not. That is, if you do trial and error, you're putting a safety risk that is not acceptable. That's why the regulation is actually asking you to demonstrate evidence that you have connectivity there. And that's why we are providing these interfaces from the telecom infrastructure, so that you have this additional information, like with wind and weather. You never have 100% assurance that is exactly like that, but it adds a safety level that is required to actually make this safe and scalable.
Most of our conversation has focused on things that fly below, call it 150 meters or 400 feet. How does this conversation apply to aircraft that fly above that threshold?
Well, there's different requirements. We see, for example, as I mentioned also during the conversation, we are working with in some countries, we are working with terrestrial infrastructure that, for example, sits on towers that go up to 250 meters, 700 feet, 800 feet. Towers of that altitude serving the airspace up to 3,000, 4,000 feet with 4G, 5G access technologies. So that is already also one of the considerations, because that technology is rock solid and it is the best way to actually provide digital infrastructure in that airspace. Many cases it is maybe governmental related, but there's also, if we look into Scandinavia as an example, the forest industry, there is not much cellular where they are using or want to deploy drones for all sorts of services. So there's a demand for that as well. And again, there's in other places we see, and we're working with satellite companies, not as an example, to provide satellite fallback where there may not be terrestrial. So there's sooner or later there will be more and more infrastructure, digital infrastructure serving the airspace, because for a telecom operator, the airspace is, it's an IoT, an Internet of Thing, because essentially what you do is you control a device through safe and reliable communication in somewhere. And in that case, that sensor or that utility just happens to move in airspace. So from a telecoms perspective, it's an aerial IoT system. And connectivity is one aspect, but providing end-to-end systems, end-to-end services for these aerial IoT capabilities is clearly also in the highest business interest, as some of these drones for inspection, they're generating something like 1 terabyte of data per hour. And so there's a huge business opportunity also that goes beyond the safety related aspect, because these airspace users generate a lot of data.
So speaking of business opportunity, tell us a little bit about Airborne RF, the company, and your products and what you sell and how you're doing, how you're generating revenue.
All right. So, well, what Airborne RF does is we're providing a bridge between the telecom industry and the aviation industry. So for the purpose of providing all the different levels of data that goes for forecasted data, airspace analytics, digital twins in the airspace, so that drone operators can actually access that data, and by doing so they can significantly enhance their processes, get this data that was perceived impossible several years ago. Now they can get live feeds from the telecom infrastructure so that they have an additional data layer for making the best possible decision on how to deploy a drone safely, where is a business opportunity actually viable, and where they can do a proper broadband service up in the air. In the same context, we help the telecom providers to understand how does their existing infrastructure that is built and planned and optimized for the ground, how does that already enable services in the digital airspace? And by doing so, we give them the opportunity to say, number one, they can engage with enterprise customers. For example, typically railway customers are in many cases IoT enterprise customers of the telcos because they have so many sensors connected to the cellular infrastructure. At the same time, these railway companies or energy grid providers want to inspect their infrastructure because they have a legal obligation to do so. Today, they are using helicopters and others to inspect power distribution networks, pipelines, and so on. And if they can automate that with a sensor and do that as a service that comes as an IoT end-to-end service, they just order the service. That's why they're hugely interested in having these automated beyond visual line of sight drone operations. And we help the telcos to demonstrate where this can be done and to essentially engage with this new industry segment, because the fact that aviation never needed cellular also means these $2 trillion businesses, industries, aviation and telecom, historically have no touch points. They don't deal with each other. But now with uncrewed aviation, there is a lot of business opportunity on how they can engage with each other. And what we do, we help them to engage with each other without the need to understand the respective industry.
So, Thomas, we have a big audience listening. Let's say there's a customer you most want to bring on board. Who is that customer, and how would they contract with you, and how big of a contract would that be?
So, to give some examples, we're working with the likes of British Telecom, Vodafone, T-Mobile. So they're our customers, and they're deploying the airborne RF solution in their networks so that they can engage with aviation partners and customers and enterprise customers that they already have. We are therefore providing a platform as a service to the telecom operators, and at the same time, we are connecting the telcos with some of the largest drone operators out there. So because they express a need, and what we do is we connect them with the respective telecom providers so that they can access the data through a fully automated interface and bring that additional telecom data, that connectivity information and the ground risk information into their platforms.
How big of an opportunity is this for you and your competitors? I mean, is it 10 million, 100 million, billion?
PricewaterhouseCoopers did about half a year ago a study where they're expecting about 900,000 commercial BVLOS drones in the UK by 2030. So 900,000 drones doing services in the UK airspace. And they're expecting that to have a business impact worth about £45 billion per year.
But what does it mean for you, though, for what you do?
What we are doing is, what we expect to happen is that for the flight conformance, for the monitoring, for the approval processes, and so on, they will every flight will need some data feed, And we expect that the majority of these data feeds will actually run through our platform. And that is where we are getting rewarded.
Do you have direct contractual agreements with the operators as well, or does everything go through the telcos?
At the moment, we are working with the telcos. We do, however, see a huge interest from large-scale system integrators who want to have some additional aggregated capabilities. And we do have a technology that is called Airborne RF Hub that actually allows some of this data to be aggregated. So that will change some of the dynamics sooner or later, so that you have essentially, I call it the iTunes store for data in the airspace, because drone operators as such would like to have a single go-to place where they can access the data, and they don't want to deal with, for example, in Europe, 4 or 5 different telcos in a country. They want to get the best possible and the aggregated information for that.
What's the relationship between Teoko, Airborne RF, Dimetor?
Airborne RF is the product. Dimetor is the company that developed that. I happen to be co-founder and CEO of that. And Teoko is a global distribution partner of Dimetor. And I happen to work for Teoko as well.
Thomas, forward 5-10 years from now, what does the industry look like as it relates to connectivity?
In the 5 years plus future, we expect to have fully automated drones, enabling a huge variety of application cases in so many industry verticals. And to have fully automated beyond visual line of sight drone operations, it's mandatory that you have not only connectivity, but also actual information about where you will have what level of connectivity, so that you can automatically dispatch these drones. So with that, we believe that the BVLOS drone operations, they will really only scale if the processes can be automated, and for that you must have a digital infrastructure in the lower airspace. And that means that the telco and the aviation industry will move a lot closer together than they are today.
What innovations would you ask for from our listeners that may come about as a result of this occurring?
There's multiple levels that are important here, because traditional aviation industry is thinking in terms of timeline in decades. Telecom operators are thinking in terms of months and quarters. And so there's this, overcoming this gap means that we will see a lot more large scale operations where telecoms and the aviation are coming together. And we can support them in crossing that bridge. That is what we are really after, to help as many as possible to accelerate the overall business.
If there were some misunderstandings on the topic, or if there's skeptics, how would you address them right now? What's the greatest misunderstanding that you'd like to address?
The greatest misunderstanding is probably that cellular is not appropriate for aviation and not appropriate for, safe connectivity. Practically speaking, it is about the only possibility or the only technology that will enable mass beyond visual line of sight drone operations in the lower airspace. There is literally no other comparable technology that is widely available, cost effective, light, energy efficient, and so on.
And what advice would you give to someone looking to build a business in broadly advanced aerial mobility? And perhaps what are some of the areas where innovators should look into?
The biggest innovations happen at the intersection of industries that did not have anything to do with each other, but now have a great path forward. Telecom and aviation is one of these intersections. So for anybody coming from the aviation side, my advice would be team up with somebody also from the telecom industry to actually bring things into the field. And from the telecom perspective is make sure that you are actually looking into the skies, because there's a significant business opportunity out there, and you don't want to miss out on that.
Great, Thomas. Hey, how would you wrap up the podcast?
I think the key message is telecom and aviation are really coming together. They will drive exceptional business opportunities that we have just not seen before.
Yeah, thank you for the time and sharing about the the dynamic performance of these networks. It's I think it's a very interesting space to learn more about.
Sure. Excellent. Well, I thank you very much for your patience. And if there's anything I can do, please let me know.
Sounds great. Thank you very much. All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and/or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.